computer. Okay, so we're going to look at some more problems from Math 65, Module 10. So this is looking at graphs and solving these graphically. If we had two equations, like this already said y equals, and this one said y equals, and then we wanted to know, essentially we wanted to be able to use Desmos to graph where this equation is greater than this equation. So if we go to Desmos and we can type these in, and in fact, oops, that's Facebook. Desmos is what I wanted. Okay, so we're gonna get rid of that. That was from our previous example. So what's cool about Desmos is you can actually log in. You can create your own login. I'm not gonna type in my login now, but you can even save these graphs. And once you get a graph, you can share it and it will create like a link, a URL that you can share. So on here, I'm going to type in, and I'm going to just type in, you don't even have to have the y equals actually. So I can go 1 divided by 4, that's 1/4. And then that one was x cubed. To do cubed, I do a to the b, and that gives me, that puts me in the exponent. And then I can type to the 3rd power. So this is what a cubic function looks like. And I'm just playing around with the scale because this is a touch screen. I can like use my fingers to zoom in and out, but you can also play around with how this looks, you know, by shrinking or expanding the X and Y axis. You can also do that over here on this little gear icon. You can say like you want to start maybe at -10. And you want this to go to +10. And then same thing on the y-axis. But as soon as I move it around, it's going to change. So anyway, that's typically what you'll see, right? And then the next one was y equals x. So y equals x. And you can see that they are crossing each other. So there's some points of intersection there. And so the first question from WebWork on this problem, this was number 15, asks, what are the point of intersection? So we can see that there are 3 different points of intersection. And then if we say, what are the solutions? Where are these equal to each other? They're equal to each other when x is -2, x is 0, and x is 2. So that's why we put that in set notation. So for part B, the first part was like, where does y equals this and y, oops.
Yeah,
y,
what A is y, what are the points of intersection?
And so those are those ordered pairs.
And then B is solve.
Yep.
Your set notation.
Yep. And so for solve, we only care about the x coordinates, and these are the solution, the x values, and we call this set notation. Now, if I wanted to say, where is one of these greater than the other, we look back on Desmos, we can see, where is the green line going above the purple line? Well, it's happening in between -2 and 0. So that's an interval, right? And then the green line dips below the purple line. And then over here, it's greater than as well. Now, something you may or may not know about is what's called function notation. So we could say f of x, let's see, I haven't typed it in here in a long time, parentheses, f of x equals, so that's really the same thing as saying y equals. Okay, maybe I named this one something different. F of x just means y is a function of x. So we're taking away that y equals, although I'm not even going to bother with that one because I'm just jumping around on there. But what if I wanted to say, where is f of x? And that's more to type in. I understand, just type all around. Where is f of x? I forgot the x. Where is it greater than y? F of x is greater than y. I don't know if this is actually helping you to understand where f of x is greater than y. It should be in these shaded areas, although it's shaded underneath. But really, it's actually just that interval. Yeah, I don't think that's as helpful.
Could you annotate it?
I don't know. Oh, on the screen, can I write on the screen?
Yeah, maybe.
I can't. Okay, well, what I'm going to do is I can actually take a screenshot. Hold on. There we go. Now, if I put that screenshot into.
That's how mine makes me do it too.
Yeah, save photo. Okay, now if we want to add in the photo, there we go. So essentially, when we look at this graph, and now the graph is underneath all my numbers. So we're looking at this area here where, and over here, because basically where is the green line going above the purple line? And that's from when x is -2. So we say, and it's greater than, not greater than, or equal to. So when f of x is greater than y, in this case, just because I named the other one f of x, so I would have two different, things to call it. I can say -2 to 0, and then we do u for union, because we're going to put two intervals together, because there's another place where it goes above that line, which is from 2 to infinity. So that should be the interval, right? For that answers the question.
For part C, yes.
C, when is if we took out these y's, it basically looks like this, right?
Yes.
Yeah. So that solution then is going to be that interval. Somebody had asked about set builder notation. Another way to write that interval would be in set builder notation. And you would say, okay, the set builder would be x such that, okay, now how do I put this as an inequality? Essentially, x is in between. So you'd have -2 is less than x, which is less than 0. So x is in between those, or x is greater than 2. Does that sort of make sense? That's just another way of saying the exact same thing. But the interval is almost a little bit easier because you can find it directly from the graph. Did you have another question? Anyone else about that one? We can try the next one if that would help too.
I think, yeah, that would help.
Okay, great.
Do the next.
Yeah. So for the next one, I could do the similar thing. I could take and put it into Desmos. And if I was logged in, I could save that so that I could go back to that graph time and time again. But the next one says the square root. So there's the square root of x plus 4, right? Was that it?
Oh, sorry.
For
Square root
17.
of x plus 4, yes.
Yeah. Okay. And then the next one was, what was it? Can you read it to me?
4x squared.
4x. Oh, actually, I think I'm going to need, that whole thing is divided by 36.
Yes.
I'm going to do parentheses. 4x
squared.
Plus
x. Plus 3.
Plus 3.
All divided by
All
36.
So I did see how I need that parentheses, because otherwise at the end, if you just put divide by 36, it's only going to go underneath the 3.
3.
So that's why the parentheses, when in doubt, we need parentheses. So now we can see here are the points of intersection. So the points of intersection are the ordered pairs. If we look at the equation, when we set those two graphs equal to each other, the solutions are going to be the x values. Now, when it asks, when is the red line, that's the, actually here, I'll just put that screenshot like I did before. And that way I can write on it. That'll be easier. Okay, let's move this one out of the way. And we'll add in the other one. Oops, that's not it. Okay, so here, when we're asked the question, so part A, the points of intersection would be part A, right?
Yes.
B would be just the X values, -3 and 5, because that's when they're equal.
Yes.
And if we're answering this question, when is the radical equation, that's the square root here, when is that red one greater than the quadratic, which is the parabola? And it's a quadratic because it has x to the second power, so that's why we call it a parabola. So the red is greater just in this place right here. At the endpoints, it's equal, but in the middle, it's greater. So how would we describe all of those points? That's an infinite number of points. So that's why we use the interval. We say when x is -3, or actually not even equal to, but from -3 all the way to when x is 5, essentially the y values are going to be greater, right? And that's what makes the line go up above the parabola. And so that would be the interval. That's confusing a little bit because the interval looks like it could be an ordered pair, but it's not an ordered pair. It's because of the context that we know it's an interval and not an ordered pair. So even that might be a little bit tricky. Like, why is Desmos, or I mean WebWork, recognizing that as an interval as opposed to an ordered pair? But if I wanted to put it in set builder, we would put set notation x such that x is essentially in between these. So we can say -3 is less than x and x is less than 5, and close that down. So there's interval notation, and there's set builder notation, and essentially they mean the same thing. It's just we learn them both because we use them kind of interchangeably, but different ones for different contexts based on what the question, what is asked in the question. So in the Desmos question, it might have said to use an interval, or it might have said to use set builder notation, or it might have accepted both or either. Okay, any other questions or thoughts on this?
Not on this one, thank you.
Okay, great. All right, should we close this one down then?
Sure.
Okay.
Let's do Ashley's question.